Hello, algebra students. Let's get going here. All right, chapter 3, extra credit. Describe the solutions, right? The answers for the following in words. So I've always taught you to rewrite this with the variable on the left. So you're going to want to take that n and move it over here. It is still open to the n. Do you see how the n is still open to it? So now what is that? N is greater than 5. So it's everything greater than 5. Not equal to. There's no equal sign there. So that would be a. So make sure you always flip it. Next up, graph this inequality. K is less than or equal to -1. Okay, so you need to go ahead and label your stuff here. And less than or equal to -1. So I'm going to circle the -1. And it does have this equal sign. So I'm going to fill it in. And less than. So we're pointing the same direction as that inequality. It works out nicely when the variable's on the left. Number 3, W is greater than 2.5. So you can still number them the same way. That's no problem. So you can still do, 0, 1, 2, 3, 4, -1, -2, -3, -4, and find 2.5. Where's 2.5? So here's 2, and here's 3. So a half would be right in between. So you can go ahead and put a marking there. And then you would circle it. And it is not equal. There's no equal sign there. So I leave it open, and it's greater than. So it points to the right. So I will go ahead and very clearly show what direction we're going. Question for you. What if I would have said this? X is greater than -√25. So at this point, kiddos, if you do not have your piece of paper in front of you to do other extra problems, you might want to grab that, unless you have room on your page. But I'm going to guess you probably will not by the end of this, so I would grab a blank, pause this and grab a blank piece of paper. Okay, so go ahead and graph that one. Pause the video and do it. Okay, sorry, I'm thirsty. All right. So when you are looking at this, the square root of 25 is, of course, 5. So I have x is greater than -5. And now we will just go ahead and graph that. So you would get the -5 on there. I'm shoving it in here. It is not filled in, and it is greater than, so it's going to go off to the right. All right, now we do the opposite. So here's the graph. You come up with the inequality like these. Okay. So, variable of any sort, doesn't tell you what one it has to be. I see I've got it on a -3, so I'm going to put the -3 there. I see that it is going this direction, so it is definitely going to line up that way as well. And I know there is no equal sign because it is not filled in. All right, next. An essay must be at least 500 words long to be accepted. At least 500 words long to be accepted. Okay, so we have a few things here that you guys need to do on the test so you don't forget. Define a variable and write an inequality for an acceptable number of words in an essay and graph. So we got 3 things we're doing here. So the first thing is I'm going to pick a variable, and I'm just going to call it W because we're talking about words. So W would mean words. Okay, so I have defined my variable. Now I'm going to write my inequality. What does it say about the number of words? It says it has to be at least 500. So can it be 500? Yes. So it's got to be at least, meaning greater than, or it could be equal to 500. All right, let's graph it. Greater than or equal to 500. So I find 500, I fill it in. It is equal, so I'm going to fill it in. And it's going to go to the right. We're all done. Now, I want to caution you a little bit, and I want you to have you try this. What if I gave you a question that said, ice is not safe. Like if you're going to walk on ice on a lake, it's not safe unless, and if it's less than 3 inches, it's not safe. Okay, so what would it be if it was safe? So you got to be a little careful, because in here it followed through with what it said. It said an essay must be this to be accepted. So then it would also ask, what would it be here to be acceptable? So here it's saying if it's less than 3 inches, it's not safe. My question is, well, what would it be to be safe? And so you could put, T could be thickness, right, of the ice or something like that. Pick whatever you want. But then what would this be? What would be safe? That was my question. Because this is not safe. So you got to read really carefully. And it's not safe when it's less than 3. So would it be safe to be 3? Sure. Or equal to 3. Of course, and then graph it. But I just am putting that out because sometimes what you're working on down here is exactly what they're asking. But if you read it real carefully, sometimes it flips and it says, an essay must be at least 500 words to be accepted. But then down here it might say, okay, but what would it be not to be accepted? So you got to make sure you read carefully to understand. Oh, wait. Let's move on. Next. Solve each inequality and graph. So remember, it's the same when you solve inequalities as regular ones, except for the division or multiplication of negative numbers. So I draw my line to see my balance, and here's my variable. So I need to get rid of what's with the variable, which is the 31. Those are gone, and I have x is greater than negative 26. So I've taught you always put this on the left side and rewrite it. I'm not changing, I'm rewriting it. So it opens to the x and it still opens to the x. Now graph, so that you don't make the graphing mistakes. So on here you can just put a part of the graph that you want. So negative 26, negative 25, negative 24, negative 23, etc. And we would circle negative 26. And would we fill it in? Nope. And we would go to the right. All right, excellent. Now, onward. Same thing, draw your line, locate your variable. It's on the right again, so I see that I'm going to have to rewrite this before I graph it. I'm going to add 4. And I'm not going to panic because I see a fraction. I'm not going to do it. Because it's actually quite a simple thing to add together, isn't it? Because that's a whole number. So 4 plus 1 2/3 would be what? 5 2/3. But again, I've taught you to rewrite. So we're going to put the y. It's opening to the y, so it's still opening to the y. And now we need to graph. Okay, so let's see here. Okay, I can hear my son coming home with his loud car. Do you guys hear that? Yeah. Okay. So, yeah, hear it now. Now, when it says 2/3, just understand there's 3 chunks there. So if it's 5 2/3, here's 5 6, and there's 2 lines, but there's 3 chunks of space. So I just want to go to the 5 2/3. So right here, and it's going to be greater than that. So I'm going to circle that, and it's going to go off to the side. All right, next. Draw the line, locate the variable. Oh good, variable's on the left this time. I don't have to worry at all about divide. We're not dividing or multiplying by negatives yet, so it's all fine. Everything stays. Negative 4 is here, greater than this direction. And you can keep labeling the other sides of it. I just want to keep moving here. Trying to make this video a little shorter for you. All right, next one. During a sale, customers receive an extra discount. They spend $200 or more. Oh, they receive an extra discount if they spend $200 or more. Sorry, finish the sentence, Kathy. All right, well, that's Mrs. Silva to you. So far, Aaron's purchases total $135. Which inequality can be solved to show how many more dollars, D, she must spend to receive the extra discount? Okay, so she has spent $135. She's adding D, how many more? And it says here that you have to spend $200 or more. So it would include the $200 or more, so the answer is going to be B. All right, next, we're going on to our solving where it involves multiplying and dividing. And so, let's take a look. We're going to draw our line. We're going to locate our variable. I just don't like using that purple. Like that blue. And I see that I have a negative 4. The negative 4 is not being added to the x. It is multiplied. There's a multiplication between there. So I need to divide by a negative 4. And now, red alert. Red alert. Okay? Why does it red alert? Because you divided by a negative. So that means, what was that variable? Anyways, an x. Sign switches. Okay, because you divided by a negative 4. So 64 divided by 4, negative 64 divided by negative 4 is 16. And you are done. Next. Draw your line, locate your variable. Okay, I got a fraction there. Remember, when you have a fraction, you can just multiply by the reciprocal. What's the reciprocal of 4/5? Because these are multiplied. So you're really dividing by it, which is the same as multiplying by the reciprocal. So I'm going to put this over 1. I don't have my alarms going off, notice, which I hope you liked, because this is positive. The fact that this is negative is irrelevant. It's what you're multiplying both sides by. So these cancel, gone. H is greater than or equal to. Now I can cross cancel here. 1 and 2. And I have a negative 5 over 2. And we're all set to go. How about I show it to you? There you go. All right. We're moving. Page 2. All right. What is going on here? Something's not right. What is right? That's weird. Okay. Oh, there we go. I didn't have it on the screen. All right. Shares in stock of a new company are selling for $3.75 per share. If an investor has 800, which inequality can be solved to show the number of shares S he or she can buy? Okay, so he has only $800. So when they take the $3.75 per share, and remember the share is right here, it's S. So they're going to multiply this times the S. And they do that in every one of these. But the question is, he only has $800. So he can't go over that. So when they multiply this times this, it has to be not only less than 800, it has to be equal. Because he could spend all 800 if it was equal, or less than it, but he certainly can't go over it. And that's what these are. These are going over. This is not including the 800. So it would be G. All right, next. Now you see these, and we don't have to panic, right? Because we can get rid of the fractions really easy. And if there was, I mean, there happens to be a 2 in both here, but if there was a 2 and a 3, let's say, I would get rid of the 1 under here. So find the variable. It's this fraction you want to get rid of. So whatever number is down here, you're going to multiply both sides by. So we're going to multiply this side by 2 and that side by 2. Works out nice over here as well, but it doesn't always. So we have 1 is greater than, but here's where it's really slick. It's gone. So I only have this top part right here left over. So -1 plus 5n. Now, this is positive, so there were no alarms, were there? I don't have to worry about that. I'm going to add 1, add 1. I'm going to divide. This is multiplied, so I'm going to divide by the 5. So I have 2/5 is greater than n. And again, the n is on the right, so I need to rewrite it. N is less than 2/5. Now in this case, you're not actually graphing it, so if you had it like that, it wouldn't be wrong for sure, but I'm just, in general, getting used to writing with it on the left. Okay, I want you to do one. So flip over your paper or go to somewhere else and do this one. Copy it down and pause the video. All right. So you should have it done. You should have an answer. I have not done it yet, so I do not know what the answer is yet. But I do know that I want to multiply both sides by what's under the variable part, so the -2. So just like the other one, I'm going to multiply by -2. And the alarms go off again. Correct? Because we're multiplying by a negative. So immediately switch. Okay, this does reduce, but I have a -1 now. And this is gone. Now I'm going to add my 1. 0. Let's see if you guys got this right. Divide by 5. Anything, 0 divided by anything is 0. So that is correct. Or if you rewrite it like that. Did you have that? If so, you are well on your way to an incredible grade. Okay, let's take a look at the next one. This looked overwhelming to some of you at first, but remember, you just need to do order of operations and break it down. Any powers you want to handle first, because you normally do parentheses, right? PEM does parentheses, but there's nothing I can do because of the variable right now. So I want to get rid of this power. I want to look inside that parenthesis and simplify it. So 2 to the 3rd is 2 times 2 times 2, which is 8. So now be very careful. You do not subtract those. 18 minus 2. Not happening. Because you have 2 times this whole parenthesis you need to do first. You got to get rid of that parenthesis first. So I'm going to rewrite this left side. Rewrite this. Because now I need to distribute that to both sides. So what is -2 times 8? -16. -2, -a. +2a. Great. All the parentheses are gone. I now need to combine like terms. So I look over here and I see, oh, -4a and a +2a. It's on the same side of the line, so I can just combine them and I get a -2a. 18 minus 16, now I can do that, and it is 2. Continue. Here's my variable. I want to get it alone, so I'm going to subtract the 2 first. So I get a -32. Okay. Then I am looking over there and I'm like, okay, what do I have to do next? And I end up having to divide by a -2. Okay, alarms go off again because I just divided by a negative, and I have to switch that immediately. Immediately we switch it. Okay, now I rewrite it. They're different. Rewriting doesn't switch anything. It may appear to switch it, but it's the same exact inequality, just written differently. Okay, this is switching it when alarms go off. Okay, so great job. Moving on. The average of Cindy's 3 test scores must be greater than 6. We talked about this in class, and when you're averaging, you're adding up the number of scores there are, and you're dividing by how many. So if there's 3 tests, then there's going to be 3 things that are going to get added together here, and you're going to divide by 3. It says that when they do that, it must be greater than 70. Greater than 70. For her to pass the test. So let's see, what were those scores? She got a 76 on the last one, and she got the same score on her first and second one. So pick a variable. We don't know what that score was, but whatever variable you pick, it's the same variable. Okay, great. Let's figure it out then. What score could she have gotten on these 2 tests? Well, let's first of all simplify, because we have 2x plus x is 2x plus 76 over 3 is greater than 70. Now, one moment, my son is texting me. What kind of world are we in when you're in the same house and you're getting texted? That's bizarro. Ask Dad. Sorry about that. Okay, now we need to remember it's one of these deals. It's underneath the variable. Let's get rid of this. So we're going to multiply by 3. 2x plus 76 is greater than 210. Subtract 76. And what is 210 minus 76? 34. How about 134? And then we're going to divide by 2. And we get x is greater than 67. So I hope that makes sense. All right, let's take a look at another one. Solve. Okay, so if you look at this, I'm hoping you see that you need to get rid of do the distributive first. So we go like that. When negative 3 times x is a negative 3x. Negative 3 times negative 1 is a plus 3. And I'm going to rewrite the right side. Okay, get the x's together is our next step. But as you notice, when you add 3x to both sides, they are gone. So you're left with this statement. 3 is greater than negative 2. Is that true or false? That is true. 3 is greater than negative 2. That is a true statement. When you get a true statement, it's not always true. You got to determine if it's true. This case, it's true. So if you get a true statement like that where all the variables are all gone, that means that all real numbers are your solution. That means you can put any number you want in for x and x, and this whole thing will always work out. Always. Every real number on the planet. It's a lot of answers. So instead of writing them all out, we put all real numbers. Okay. Next. Draw your line. Locate your variable. Do not panic because of the fractions. That's your first step. Now, this is different than, where was it? This. Okay, this had the 2x plus 76, and there was one fraction bar with the 3. And that's why we multiply both sides by 3. This is different. This is over here by itself, and this is over here by itself. So the first step you need to do is get rid of this. Get this over here. So I'm going to subtract 15/16. And when I do that, I need to get a common denominator. So I'm going to multiply this by 2 and get 16, and I'm going to multiply this by 2 and get 14. So I have 14/16 minus 15/16, and that is a negative 1/16. These are gone, which is less than negative x over 6. Don't lose your signs. Okay. Now I have to, I said, no, that I'm making a video right now. I am making a video. Oh dear. So when we do this, we want the x alone. And I need to get rid of the 6, and I need to get rid of the negative sign. So what shall I multiply both sides by? I can do it in one answer. I can do it by multiplying both sides by a negative 6. That's right, negative 6. So the negative canceled out with this negative, that's a positive, and I'm left with x, and I switch the sign because I don't want to forget. Okay, and negative times negative is a positive, and this is a 3, and this is an 8. So I've got 3/8 is greater than x. So, rewrite it. Voila. I was about to say questions, but you can't really answer. So, all right, 18. Juan is making birdhouses to sell at a craft show. The cost of making birdhouses is $80 plus $6.25 per birdhouse. Okay, so he's going to sell them for 16 each. What's the minimum number of birdhouses he must sell to actually make a profit? Okay, so what they're saying there is he's got a set price. To do this, he's got to spend $80 and then an extra $6.25 for every birdhouse. So let's get an equation lined up. So he's got to spend a straight $80 up front, and then he's going to spend $6.25 per birdhouse. Now he was going to sell them for 16 per birdhouse. So what's the minimum number of birdhouses he must sell to be able to make a profit? So which side would you want to be bigger? In order for him to make a profit, which side has to be bigger? Right, the side that he's selling, right? The money that he's selling. So I'm going to put a greater than there. Let's solve. Oh, I've got x's on both sides. I got to get those together first. And then 16 minus 6.25 is 9.75x. Okay, these are multiplied, so we're going to divide by 9.75. And what do we get for that? 8.2, I see. 8.2 and less than x. So I'm going to rewrite it because it's more understandable that way. So I'm going to rewrite as x is greater than 8.2. Okay, guys, this is a real life problem. The question is, what is the minimum number of birdhouses he must sell? You cannot say 8 because he needed at least 8, quote, 0.2, although you can't have 0.2 of a birdhouse to sell. So he's going to need to have 9. Okay, you don't round down. That wouldn't give him enough money. He wouldn't make anything still. He'd be just shy of it. In order to actually make money, he's going to have to make 9 birdhouses. Okay, next. Solve each inequality. Now when there's 2, you just draw the line twice. You still find the variable, and you want to get it alone. So it's adding 5, so I'm going to subtract 5. And I get negative 13 is less than or equal to C is less than negative 6. It is a less than, so I know my graph is going to look like a barbell. So let's see here. I'm going to go at negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5. Okay, so negative 13 is here, and negative 6 is here, and its C is less than negative 6, so it's going to go this way, and C is greater than or equal to that. It's going to go this way. So again, it does look like a barbell, but it also makes sense if you just look at these as two separate inequalities as well. So make sure you include, if it's equal, you got to fill in that circle real obviously to me. Okay, next. Right away we see or. So we think we're going to have oars, like on a boat. Okay? So let's solve each one of them. Minus 1, minus 1. 4a is greater than negative 16. Divide by 4, divide by 4. A is greater than negative 4. So there's my first one. Or, well, it's in the bottom. Remember, multiply both sides by a negative 3. One moment, please. One moment, please. That's right. I get the negative 3 here. So I have A is less than or equal to negative 7.5. So A is greater than negative 4. So I'm just going to do negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So A is greater than negative 4. So where's negative 4? Right here. Equal? No. There's one or. And A is less than or equal to negative 7.5. So here's 7 and 8. So I find my little middle spot, fill it in, and it goes left because it's equal. There's my ors. Now, again, tell me the inequality for that. Well, first of all, is it an and or an or? It's an or. Oh, I forget. So put it right on the line there. And then I need to put each of them down. So x is, what is this? Less than or equal, right, goes that way, to, what is that? So you got to figure that out. So it's 0 to negative 1, and there's 1, 2, 3, there's 4 spaces. So that's splitting into fourths. So that's 1, 2 fourths, which is a half. But it is a negative because it's a negative 1. And over here, x is greater than, not equal because it's open. But again, we are splitting it into fourths. And that is 1/4. And it's positive because it's on the right side. All right. Next. Okay. Solving absolute values. You always have to get these alone. So I have a net minus 1.8 on that side that I need to get over here. So I'm going to move that first. So I'm left with this, which is negative 2.2. So let's evaluate what we have. Absolute value of 3x plus 2 is greater than negative 2.2, huh? Absolute value is a distance. So this is always going to be a positive number. How could a positive number ever be greater than a negative? Like all the time, right? Always, right? A distance, a positive number. No matter what you put in there for x, when you take the absolute value, you'll get a positive number. It will always be bigger than the negative. So you don't even have to break that one down. So I would recommend when you're working in these, you always just evaluate to see if it's a situation where it's like, yeah, all the time it will work out to, if there's a negative here, you want to take a look at it. Sometimes, what if this was less than? When will a positive number be less than that? Never. So that would be no solutions. So you got to kind of take a look at it. Let's look at the next one. All right, draw your line, subtract 3, and then we are going to divide by 2. And we are then going to split it. So then we have one of them is exactly the way you see it, right? And one of them does two things. Less than and opposite sign. So those are my two answers. X is less than a negative 7.5 or X is greater than. So remember, one looks just like it and one flips the sign and the positive or negative value. Okay, good. So I have just a couple questions I'm going to have you try on the back of this or somewhere. So flip it over to where we were, and I want you to solve this. 3 more. That's it. I have 3 problems for you to do. There you go. Copy that down. Stop the video. Solve it. All right. So I'm going to draw the line. Add 10. Absolute value of 3x is less than 3. So I'm going to break that down to 3x is less than 3. Exactly what it says without the little goalposts there. And then I'm going to have 3x, and I'm going to do the other two things, greater than equal 3. All right. So solve each of these. So x is less than 1. X is greater than negative 1. And is it and or is it or? Less than and. Okay? So you could put it in that form as well. And it would be a barbell. Okay. Try one more. Okay, stop the video and do it. Okay. Draw your line. Got that negative over there. I want to take a look at that. We just talked about how that's a distance, so that's always positive. When is a positive number less than a negative? Never. No real solutions. Right? Positive number will never be less than a negative. So that's done. I don't even have to break that one down. Okay, well, last one, grand finale. And we'll still get done earlier than the last video. If you have something where you're going to earn, let's see here. I just scribbled notes. So I'm trying to figure out what I meant by this problem. Let's say you're going to earn $2,600 a month. A salesperson that earns $2,600 a month. Okay, salesperson 1. And salesperson 2 is going to earn $500 plus she's also going to get 5% of the sales. So whatever they sell that month, she's going to get 5% of that. And I say, okay, well, what amount of sales would the second person need to earn to be more than the first? That's the question. What amount of money, what amount of sales would be needed for this person to earn more than this person? Pause the video and try it. Okay, so let's get an equation, an inequality. So we want to know when this will be bigger than this. So I'm going to write that. 500 plus, change it to a decimal, of the sales. We'll just make X of sales. When will that be bigger than my $2,600 straight up that person gets? Because you want to know. I mean, it could be a much better job here, depending on what kind of sales they get at that place, whatever they are. So solve it. Minus 500, minus 500, 0.05x is greater than 2,100. And then we're going to divide. And what is that? I don't have my idea of this. My alarm system. Let me just save time and do that. Alrighty. One moment, please. That's what I came up with. Whoops, can't see a darn thing. Okay, so if the sales were $42,000, they were more than $42,000. Let's be clear, not equal. More than $42,000. This is the better job. If they're less than $42,000, that's the better job. All right, that's all she wrote, folks. Take care. We'll see you soon. Bye-bye.